Think about how we learn. We go through things, we mess up, we have some wins, and we remember, right? That ability to learn from experience is pretty much what makes us smart. But for AI, learning has always been a totally different ballgame and honestly a much tougher one. So let's get into a really cool new approach that's teaching AI to remember a lot more like we do.
And this is the million-dollar question. Right now, if you want an AI agent to pick up a new skill, it often needs something that feels a lot like brain surgery. It's this super complex, expensive, and time-sucking process called fine-tuning. But what if there was a better way? What if we could just skip the surgery altogether?
To really get why this new idea is such a breakthrough, first, we've got to understand the problem everyone's facing. See, today's AI agents are kind of caught in this fundamental dilemma when it comes to learning new stuff.
They're pretty much stuck between a rock and a hard place. There are really only two options on the table for how they adapt, and frankly, neither of them are great. So on one side, you have these static agents. They're rigid. Their logic is hard-coded. They're awesome at the one thing they were built for, but the second you need them to learn or adapt, nope, can't do it. Then on the other side, you have agents that can learn by updating their core programming. That's the fine-tuning we talked about. But this is just wildly inefficient. It's so expensive from a computing standpoint that it's just not practical for the kind of continuous, on-the-fly learning we want to see. So, stuck with this dilemma, researchers did something brilliant. They looked for inspiration from the best learning machine on the planet, our own brain.
And this quote from the research paper just nails it. Instead of trying to constantly rewrite the AI's core, what if we gave it something different? What if we just gave it a memory? What if it could learn from its past without all that costly surgery?
Now, this idea isn't just pulled out of thin air. It's actually grounded in a solid psychological concept called case-based reasoning. And it's super simple when you think about it. When you face a new problem, what do? You think back, hey, have I seen something like this before? And you adapt that old solution. You're basically using a mental library of your own experiences to figure things out.
The researchers basically broke down our process into 4 key steps. First, we encode an experience, we file it away. Then, we kind of distill the lesson from it, the main takeaway. Third, we reinforce that memory so it sticks. And finally, when a similar situation pops up later, we retrieve it. That's the blueprint they decided to use for an AI.
And this brings us to the star of today's explainer, a new framework called Memento. And it is designed to learn in exactly this human-like way.
The big idea here is that Memento doesn't just rely on its fixed, built-in knowledge. Instead, it has this external case bank. Think of it like a journal. It's a growing memory of all its past tasks, the good, the bad, and the ugly, that it can flip through to make better choices next time.
Okay, now this diagram might look a little intense, but the idea is actually really elegant. Memento works in 2 main stages. Over on the left, you've got stage 1. A planner gets a task. Its first move, it checks the case memory, that library of past experiences, to find similar problems. Based on what it finds, it cooks up a step-by-step plan. Then, over on the right, in stage 2, an executor takes that plan and uses a whole bunch of tools, like web search or code interpreters, to actually get the job done.
So what really makes this whole thing click is the teamwork between these 3 parts. The planner is the strategist, right? It's using past wisdom to make a game plan. The executor is the doer, the boots on the ground that makes it happen. And that case bank, that's the library, the institutional knowledge that just keeps getting bigger and smarter with every single task the agent tackles.
All right, so that all sounds fantastic in theory, but you know what matters? Does it actually work? Let's take a look at the results and see how Memento held up under pressure.
Oh yeah, it works. In fact, it works incredibly well. On Gaia, which is this notoriously difficult benchmark for testing AI agents on really complex, multi-step problems, Memento shot straight to the #1 spot on the leaderboard. And this chart just paints a perfect picture. See those dark blue bars? That's Memento. Across all the different difficulty levels of the Gaia test, you can see it's consistently at or right near the top, leaving a lot of other well-known agent frameworks in the dust.
But hey, it's not just about acing complex tasks. What about basic factual accuracy? Trying to avoid those weird AI hallucinations we hear so much about. Well, on the simple QA benchmark, which is designed for exactly that, Memento hit an incredible 95% accuracy. That's a new state-of-the-art result, showing it can be both really smart and really reliable.
But maybe the most impressive thing of all is how well Memento does on tasks it's never been explicitly trained for. As you can see in this chart, when it's facing totally new kinds of problems, curveballs, its memory gives it a huge accuracy boost. We're talking almost a 10% jump in one case. So what this means is, having a memory doesn't just help it do what it already knows, it actually helps it figure out what it doesn't know.
So let's zoom out for a second. What's the big picture here? Why doesn't AI having a memory really matter for the future of all this?
Well, the benefits are huge. This approach means way more efficient learning without the insane costs of constant retraining. It means the AI can adapt in real time as new information comes in. And like we just saw, it leads to much better generalization, which makes these agents way more flexible and tough.
Look, the most important thing to get here is that this isn't just about one clever agent. Memento represents a huge shift in thinking. It's a move toward a much more sustainable, more scalable way to build AI, one that can learn continuously from everything it does, getting a little bit smarter every single day.
And that leaves us with a really fascinating thought to end on. We are just at the very beginning of building AIs that can truly learn from experience. So as they start to build up these memories, remembering not just what worked, but also what didn't, what new things will they be capable of? What kinds of problems that seem impossible today will they be able to solve tomorrow?